I'm going to talk about Swift source code manipulation. How many Swift developers we have today? Okay, that's good, because I was afraid there's more Android today, but it's not. So that's good. My name is Marcin Krzyżanowski. I'm here to tell you about an awesome world of tools to parse and manipulate Swift source code. To get started, I want to tell you a little bit about what you're gonna learn today. So first, we're gonna define not that imaginary problem related to the source code structure. Then I'm gonna introduce a Swift syntax library, and I will go through the API just shortly. Then we're gonna talk how to write tools like formatters, and after that, I'm gonna introduce another tool that is IndexSourceDB, and I use it to build a command line tool. So here's the problem. The problem is that sometimes code layout is suboptimal, and this is the problem I created, and I will present the solution to that problem. The solution to that problem is reorder some part of the source code to the desired structure. For the purpose of this presentation, I'll work on this source code. This is like an input. Yeah, you can see it's completely randomly put some fragments of the code. It's more clear when I strip out the body and just see the interface. You can see there's a public class, but there's a private, some internal, the init, internal, initializer is somewhere here, and it's private. And yeah, at the end there's the public initializer. So it's a bit of messy. Like it's hard to grasp what's going on. So what I rather prefer is to lay out that to group initializer together and public, internal, and private methods together in an order that the public go first, then internal, then private. Right? It will look like this. This is the operation we want to do. This is the expected operation from the output of the command line tool. For the second, let me discuss what are my options to get from point A to point B. I can reorganize text by hand, manually. Every time I work with a file, I will just open the file, copy, paste, move things around, and it will work. It's kind of tedious, but it will work. Another option is to use some kind of helper, like extension to the IDE, but we work with the Xcode, so it's not really an option. Or I can set up one of the available tools. If there's a rule that I'm happy with, I should adjust this tool and just put it in the flow of building or just working with the code. The tools I list here is a Swift format by Google, or Swift Rewriter. I think, two of them at least. The first one is very popular. Or I can write my own tool, right? And how hard it could be. Have you ever, so any of you work with that kind of tool in the past? Have you ever, yeah, we have two. Oh, any language, yeah, any language. Okay, 3, okay, that's great. So, be silent, please. How to write that tool? Well, to write the tool, I need a brain, of course. I need some time. I will use a computer. and I will use a programming language. My choice is Swift. And I will use a little help of specialized libraries that were created especially to solve this category of problems. There's no sound, but yeah, I have brain, so check. I also have an internet, so you know the brain and the internet is my superpower. So, and then I have some libraries, which is the third ingredient. What can I use? Have you ever heard of NTLR project? If you're like a Java programmer, you may have heard of it because it's very old and it's very good. NTLR is another tool for language recognition, but this tool is the parser generator for the language. So you write grammar, put this grammar as an input for NTLR, and it generates the parsers for the language that you specified. So you can use that generated code. We can use that, but we won't. I did. But it's very slow on Swift. There is a Swift outlet, but it's very old. I think nobody maintained that. Just Swift is not in the interest of the maintainers. We can use PCRE, which is regular expressions, regexp. You know what the regexp is. Everyone does the regexps. Can we use that to parse the code? How do you think? Would you? No. No, why? Why? Why is it perfectly good? Like it's fast, it's good. Like it's long, but it's good. Well, yeah. In practice, it's very hard to use the regular expressions from just practical point of view. The regular expression will be quite complicated. So maintaining that will be very tedious and probably very resource. It will use a lot of memory. So, in a Swift world, we have a Swift syntax. So Swift syntax is a Swift project maintained by the same guys that maintain the Swift compiler itself. And it's a wrapper around the lib syntax that is a C library and is part of the Swift project itself. Swift syntax is a library to parse Swift. IndexStar.db, I will talk about it. It's a library to work with the index of the Swift code. And we can use that as well. How does it work? Swift syntax takes the source code, which is just a text, and transforms that into the form of abstract syntax tree. You know tree, what a tree is, right? Because everyone got that question on the interview, right? Yeah. So it built that kind of data structure. Abstract syntax tree, which is AST, this is the acronym you may find here and there, is a tree-based data structure that preserves full source, meaning the source code can be written out of the AST, preserving very same characters. So we can transform source code into tree and tree into source without losing any data. One node represents a tree of nodes with tokens and leaves. Each node has accessors of its own, of its known childs, and allows efficient iteration over the child. To iterate over the tree in this library, who knows how to iterate a tree very efficiently? This is the interview question. Nobody? Okay, so one option is the visitor pattern. And this is what is used by the Swift syntax. So the visitor pattern let me visit nodes of my interest and process lazily the tree as I go. So it's iteration. Like here, I can go from syntax 1 to 3, just completely ignoring the rest of it because I don't care about everything else. How does it look in a code? Import the Swift syntax module, and I have to implement the visitor, syntax visitor, struct visitor here. One of the methods I choose, this is the method that will be triggered whenever parser will reach the initializer, which is the init. Then I do some processing on a node and decide whether I'm interested in a child or not. Here I'm not, so I return skip children, and it just do not check the body of this initializer because I don't care. We also have the rewriters, which are built on a visitor pattern as well, that allows us rewrite the tree as we go. So here, in this example, I have a rewriter that is inherits from syntax rewrite, and I implement just one method. Whenever I visit the initializer, return some bullshit, basically blank class declaration, right? And it will replace this node, this perfectly good node, with this class declaration, which is not correctly formatted Swift, but you can do that, right? Whatever you want, you can do that. It doesn't check if the tree is valid with the grammar. It's up to you. Here's the plan to build a tool. I have to search all the declarations, which is the func, so the function declaration, initializer, the initializer. Then sort functions by access level and kind. So I have a list of all the all the declarations, and I sort it so the public will be on top, the private will be on the bottom. Then I will use the rewriter to replace the declaration in the right place in the tree and output the source code. This is the indexer. With the indexer, I just get all the functions what I'm interested in and put it on the stack with an array on the array. Initializer. The initializer function, and so on and so forth. And I just remember that this is the first pass. And the second pass, next there's a sorting function, which is a bit more, this is the logic, this is the actual logic. Like, get the functions and sort it in my way, right? Based on whatever is on the left side, on the right side, right? You know how the bubble sort works. Once I have these functions sorted, I can use those to rewrite my source, right? So I write the rewriter, I do the rewriter, and same, rewriter. When you find that the initializer, just return first element from the sorted functions and remove that, and so on and so forth. And at the very end, this is the process, which is the main function that gets the data, which is the source code, run the indexer, the functions, run the rewriter that do the actual work, and output the tree formatted into the string to the outside. And that's basically everything. I just need some boilerplate, to handle the command line, which is the arguments and so, but that's irrelevant. The call of the reorder tool I just created is reorder minus file conference.swift, which means parse the Swift conference.swift file, which is shown at the beginning. And I have a working tool. That's how I invoke it. This is the output. No, this is the output. I think. Yeah, this is the output. Well, it's sorted. If you don't see it now, can you see it now? Because it's scrolled. If you don't see it now, it is available on the GitHub, so you can catch up. Believe me, it's sorted. Avec moi. You know that? It's from Asterix. No? Hi. You might think like, okay, it was like 10 minutes or something, and we started here, and we should draw the so you might have this, but believe me, that was all the code I needed to write a simple Swift formatter. This formatter is available on the GitHub. Unfortunately, you cannot see it, but it's on the github.krzyzanowski.reorder. Any homework, if you're interested in, the homework is to add some features to that. So sort properties, sort extensions. Are you laughing? But this is the second presentation I have on this topic, and somebody already did that for you. So, you're ahead. And there's one more thing, which I didn't. That from the Xcode, and this is the very same mechanism. I will not mimic the whole mechanism, but this is, if you're wondering what's going on, so this is what's going on in the next slide. There's an IndexStar.db project, framework, module, that is a source code indexing library. It provide the efficient query API for looking up source code symbols and occurrences and relations. It basically, with this library, I can ask, where is the conference class? And it will return all the files where the conference is, whether either define or extension or whatever. I can find the relations between the code. But first, I have to build the index. This is how we build the index in Swift. If the project is Swift for the Swift packet manager, we just need this enable IndexStar, and it happens. And store is located at that path, so it's somewhere .build blah 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 IndexStar. But you can also do that for the single file, just to put the database to the location what is convenient for you. So there's a swiftc minus IndexStar path, and this is the path index file and the file that you want to index. Of course, you want to index more files, so you put more files here. And yeah, it built the index. You don't see that, but I'm invoking this comment and showing what is inside. There's a structure. This index is based on the clang. You know what the clang is? Yeah. So this is the same index. With the Xcode 7, we've got this indexing mostly, and this is when the Clang project introduced the index and the indexing while building feature. So all that stuff it's shared with Swift now. Yeah, and I can use the store indexer. I can rewrite this first pass that was taking the the functions, now I can modify it a bit. So here, I use the IndexStar library. Yeah, this is tricky because we have to link to the lib IndexStar dlib. Yeah, this is how it works because it loads it dynamically. Anyway, IndexStar.db, path to the store, where to store a temporary database, and once we have that, read all the symbols. And after that, I can ask for the symbol, occurrences of the symbol. And this is what I'm doing. I'm asking for the occurrences of the symbol conference, so I will get the location of the conference class. After that, I don't have to specify the path to the Swift file. I just use the index, and the output is the same because I'm using the same rewriter after that. Yeah, so it is 15 minutes, and we have like two solutions, right? But I didn't mention about one important thing. This tool is more familiar for you. You know what you may not, you don't have to know, but you heard of it. SauceKit is. It's Bazel that SauceKit crashed in Xcode. Yeah, that's the real thing. This is the Swift project, like a tool in a Swift compile project. We can use that. However, it's very difficult to use it directly. It works like a daemon that has some protocol where the other side has to know the protocol to communicate with this daemon. But we have open source, and JP, how's it called? Simon? Smart? JP Smart.
Smart, yeah.
Yeah, I know. Yeah, so JP created SauceKit, which is great tool. It's a Swift wrapper that allows us to communicate with the SauceKit. And with that tool, you can basically be Xcode. You can do whatever Xcode does, you can do that. So there's more than just parsing, but there's like there's a call to take a documentation for the symbol at the place, and so on and so forth. So it's a very rich tool, but for simple tasks, it's a bit too much. All right, to recap, there was a problem with the order. I use a Swift syntax to solve the problem: parse, rewrite, and output. I use the IndexDB to help it to make it a bit smarter. And there's a GitHub repository where you can go clone and start playing with that and write your own Swift format tool. Because remember, this Swift format that will be part of the Swift, will be official tool, is based on a Swift syntax. So if you want to, contribute to that, this project is a very good playground where you can start. Some links. Building a Swift compiler in Swift by Nick Liquid. Nick Liquid is the author of Swift format, but it's different Swift format. We have two Swift formats in community. Adding index while building. This is from the LLVM guys, Clang guys, where they describe how this IndexDB looks internally. Creating refactoring transformation for Swift, if you're interested, because you can use that tool to build Xcode extension. Yeah, it happened that it will be the use case that will work with the Xcode, right? Well, this link will cover that. And as hipster Swift syntax, I think it's not updated, but it describes all the API of Swift syntax. But it's very, very good to look into if you are interested. All right, thank you very much.
So basically, as I understand it, the Swift syntax is related only to specific one file, yeah?
Well, the Swift syntax can load any data.
Okay.
Yes, at once, yeah, it makes sense to use it for a single file.
Okay, but have you thought about, let's say we are taking over of a big project and it's a total mess, and let's say the first step that we can take is to use this tool for the whole project.
Yeah, so this is where the index will help you. Otherwise, yes, you have to first you have a notion of the project, right? Which is normally you don't. So you use a Swift Packet Manager or whatever that will give you the files from the project, and you will use each of the file as an input to your tool. And yes, you can build like analyze all the files based on that. But yeah, this tool is just arbitrary input that you will give me. I will work with. There's no notion of a project itself.
Okay, thanks.
Yeah, right.
So this IndexDB, you can use it to strip unused variables, yes, unused symbols.
Yep. Yep.
Because it's not
It's
available in Xcode so far.
Yeah, especially it's useful if you have a function, the class declared in one file and the property in the other file, you know, so you will find this connection very quickly.
Yeah, because I think there is a tool, but I think it's written in Ruby, as I remember, to get rid of all unused code. But
Yeah, why not?
But it's not really working like reliably. You wouldn't like to put your project into it, and because then it strips some used code also. But maybe IndexDB will do the better job.
Maybe, yeah.
Does pragma is part of the Swift abstract syntax?
Yeah.
So we can like not divide the internal, public, and private methods under the same pragma mark. If we use that tool.
Oh yeah, because
Like the mark that this is like the delegate method.
yes, definitely. So it's called all the important parts are in the nodes, but everything else is called trivia. And in trivia, there's all the comments, all the stuff that is not part of the language itself, But it's still there. You can parse, you can find it, you can add it. Yes, definitely. Yeah. There's even a project, I think, based on the Swift syntax that does that. I mean, that does whatever it finds the extension, it adds the mark, pragma mark or whatever it's called in Swift now.
Okay, so this is more like an opinion request than a question. I tried working with Swift,
Hey, come on.
with Swift syntax like in January or February, and I kind of hit a wall with the old API. Do you have any comparison how much it improved since then?
Well, the API is changing, and I don't remember. Well, there was some change about the January, and they changed some API even last week. There's not that much API in the Swift syntax though. Like really, there's just a few classes now.
Like I don't remember exactly, but I think the generated files were giving me trouble because there's a lot of generation via JIT, right?
Yeah, but it happens only once. It has that's how it built. So because Swift syntax has to be very tied to the version of the Swift that it's meant to work with. While it is building, it reached to the Swift sources, like the project Swift, get some keywords from there and generate the Swift files that are later compiled and are part of the Swift syntax. Yes. However, whenever they release, and they don't release often, they do that for you. So there's a tag, which is now 0.50100, that is compatible with the Swift 5.1.1, I think. That is done for you, right? this part. You just can clone that, check out that tag, and it will have this generated files for you. And but this is a private, I think, that you don't have to use that. This is all the boilerplate, basically. To avoid the strings, I guess, mostly. Okay, any questions? Or no? Okay, thank you very much.